Today we're going to talk about properties of sound as wave. I'm showing you two pictures here, and you might think to yourself, why would I be showing you a picture of a dolphin and a race car? I just wanted you to remember that medical imaging isn't the only thing that uses sound. Dolphins use sound for echolocation. Another thing to think about is the sound of a race car flying by on the track, or a car, and how the pitch of the horn changes as it drives by. This is the Doppler effect that allows us to measure blood flow. Ultrasound waves are longitudinal waves that are propagated through tissue, and you have regions where as the wave moves the tissue becomes compressed, and other areas where the tissue spreads apart. These areas at increased compression can be represented by this dotted line here, and areas of the expansion here can be a negative valley, so that you could actually represent the whole sound wave as a sine wave. If we take that sine wave and transfer it into a diagram with a patient and a transducer, you can see that the transducer is over here on the side. This line over here indicates the patient's skin surface, and you can see the sine wave coming out of the transducer as it's emitted. The wavelength is an important characteristic to remember, and that is the distance that it takes for the sound to make one complete cycle. So if you start at this point, you go up along the peak here, down crossing the midline again, down in the valley, and then coming back to the same side. That's the wavelength. More important for ultrasound than the wavelength, and more commonly talked about though, is the frequency. This is the equation that shows how the frequency and the wavelength relate to the speed of sound. So we have frequency here represented by f, and lambda represents our wavelength, and over here is the speed of sound in tissue is c. Given that the speed of sound in tissue is relatively constant, as you decrease the wavelength, your frequency increases, and as you decrease your frequency, then your wavelength increases, because the product is always relatively stable. So this is important when we go to talk about transducers, as most of them are represented by the maximum frequency that they can transmit. So in summary, the three things that we talked about in this video are sound, how it transmits through tissue as a wave, and then the basic properties of wavelength, frequency, and speed, and how those are affected with different ultrasound transducers.